All right. Hello, everyone. Welcome to the Viking Codecast. My name is Erik Trautman. I'm the founder of Viking Code School, and this is a weekly conversation with experts in the field of development and beyond, designed to kind of help everyone who's either learning to be an engineer, is an engineer, and just wants to get better, or people who are just kind of curious about this whole development thing in general, to learn a little bit about what life is like on the other side of the curtain, and some best practices for getting yourself to that point and helping yourself level up when you're already there. This week, we're joined by Andrew Tso, who's a very accomplished developer who we're very lucky to have. And I say developer when really I think it's much more multi-talented than that. He's the founder of RocketReach, much bigger than one person company. He's done VP of growth. He's been CTO. He's been a co-founder. He's done all sorts of interesting stuff, which I really want to hear, probably Andrew, in your own words. But I think today. Very curious to hear a lot about sort of your evolution and journey from the coding side up into kind of the different levels of organizations that you've both founded and been a part of, and then some of the tips that from those different levels along the way that you could potentially offer some people who are maybe much lower down on that journey and looking upwards and kind of wondering how do you start taking those steps. So let me be the first to say welcome, and I'd love to hear just a quick little bit about kind of how you found your way here and to this particular point in your life.
Yeah, thanks for having me. So I guess kind of to answer your question, I guess I first started getting into computers I was fairly young, and it's kind of interesting. The answer to why I got into sort of this field was video games. So as a youngster, I got my first computer probably when I was around 10-ish. It was a Mac Plus, which at the time, was it was a $3,000 computer. It had a megabyte of memory. It had floppy disks, which I had to change it in and out because the operating system did not fit on one floppy disk. But it's kind of funny, and I probably shouldn't be saying this on a podcast. But what really kind of got me into it, as I said, it was video games, and the kind of interesting thing that I kind of figured out was young. One of my friends and I figured out how to actually copy Super Nintendo cartridges, and so kind of funny. We figured out how to both copy them and then also trade them, and so. It just got me into hardware. It got me into building computers. Got me into just learning the ins and outs of how a computer works. And so I attended UC Berkeley for computer science, and that brought me to Silicon Valley, which was probably, looking in retrospect, one of the better moves I've sort of made in my life, because all the innovations really happening here. You're surrounded by great talent. There's great talent, great ideas, and the capital to kind of produce great companies. So it's an awesome place. Anyway, what else can I answer for you?
Yeah. So okay. So I think we actually have a number of people listening here right now who got into this via gaming. So I don't think there's anything new about that. I guess hackers have been around ever since. Well, it's been a very long time. I remember hearing stories from my dad in his MIT days. They would hack the long distance phone services and things like that. So it's a lot of reasons to get in. So I'm kind of curious, just I guess maybe to hear a little bit more about the journey that you took, moving from an interest in computers through computer science to then entering the professional world, and what was the era like when you got out into the workforce, and then what was that transition like going from school to working?
Yeah. Okay. Yeah. So definitely it's probably date me a bit, but so I've been in the workforce for roughly 2 decades now, and it was actually a very interesting time because I got to see the transition pre-internet to post-internet, and it's just a stark difference, I guess, in both the productivity, I would say, for the average software engineer, simply because you just started to see the beginnings of hardware. People have been saying it doubles every processor speed's double every 2 years, and you get memory's been doubling and whatnot. But when I first started, we had the computer science, the computer science division, essentially had like several computers which were probably altogether less powerful than your phone, actually less memory than your phone, and you'd have like 200 people like basically sharing time on a system to program. And so like what that would kind of mean in sort of like so sort of an anecdote, like so we'd be programming in C, and like you would basically submit you would write your code, submit it to compile, and then you would probably wait a good 30 to 45 minutes if you were lucky before like the program finished compiling correctly. And like to kind of illustrate some of the pain points in that, like so if you had a syntax error, like say you forgot a semicolon, you may find out like 15 minutes later and just be like, oh, I forgot a semicolon, and then have to go back and fix it and just start all over again. So it was like a very, very different time. Like we, I mean, so it was like the workstation era before I guess PCs were like prolific, and I mean back then most people didn't have their own computer until probably like my senior, which was like around the 1995, 96 time frame. So yeah, they're very, very different. And then what that sort of translated to, like going into the working world, is so the cost structure to start a company was just orders of magnitude different than what it is now. So if you think about, there are a lot of things I think that we kind of take for granted that were sort of different from back then. So one thing was that like it probably cost, like if you wanted to professionally program, it probably cost you around $60,000 to $70,000 a year just to do that. And what I mean by this is like you had this workstation you had to buy, which was like there were probably 5 or 6 workstation vendors. Like the last one to have gone out of business was probably Sun, but then there was like HP, IBM, DEC, and they sold you an expensive piece of hardware, which was the price of a good mid-sized car, and then so you buy this workstation. There's like a software maintenance. You have to pay for the operating system. You have to pay for the compiler. The data structures that you use right now, you either write them yourself, or you could license the equivalent of like STL or one of these standard libraries. You'd have to license it for like $7,000 a year. It's just like order of magnitude different. Like I mean, like now, like you could buy a $300 laptop, install Linux on it, and like your compiler's free. I mean, like you're using these great frameworks which allow you to quickly get something up and running. Whereas back then, I guess my first job, like out of school, like I joined Oracle, and it was the division I was in was called Servers and Technology, and there were over 1,000 engineers in this group, and the reason why you needed that much manpower was because in order to, the product was the Oracle database, which I guess the one kind of interesting thing about that is that like I actually have code that might be still running, like written like maybe 20 years ago, that it's still in production, which is kind of like the testament of good engineering if you have something that's been running that long. Anyhow,
or no one can figure out how to change it.
Yeah, but I mean, it took 1,000 engineers to build out this product and sell it across all the different workstation platforms, and yeah, it's just very, very different. Like yeah, you needed teams at large just because like all the things that you take for granted to get you to the point where you could actually be productive and write code that could potentially face a user, you had to sort of write yourselves. Like for an example of this is like so Java, like which I'm not sure if you guys learned it, but like so it's infamous for being like cross-platform compatible these days because like Intel sort of won the hardware wars. Like everyone, I mean you're basically just targeting like an Intel processor, but back then we had to write basically a virtual OS to be able to cover the 10 different flavors of Unix. And so like if you think, I mean what that kind of means is like so for every operating system command that you might think of like opening a file, you actually had to abstract that such that you had to write an abstraction layer so that you could write code once and then actually compile it to basically the 5 flavors of hardware. I mean 5 different types of processors and the 10 different types of operating systems. So it was yeah, every time you release software, it was a feat.
So how different is it? Do you think it feels from when you stepped on? I guess you were kind of cutting your teeth right up leading into the internet bubble 1.0, and the kinds of roles that a programmer would step into. You were saying that you're part of a 1,000-person team building presumably a very small slice of a very monolithic code base, as opposed to someone who can now call themselves a product developer and can step in and start firing out UI widgets and then back-end services day two. How do you characterize that difference, and how does that feel?
I mean, from an engineer standpoint, I think that I think most engineers now are there's a much higher degree of satisfaction simply because a single person, to how you're pointing out, can basically build something working, consumer facing, and then potentially even money making by themselves. And that was probably impossible. I mean, not impossible, but very, very unlikely to happen 20 years ago. To give you sort of an example of my type of role, I started off as a front end guy, but I was a compiler front end guy, meaning that I worked on the parser and then basically the types of syntax tree and the types of errors that would be emitted from that compiler to the user. So and now I was one of maybe 3 or 4 people sort of working on just that one piece, which was just a tool that was used by other developers to kind of develop this product or develop Oracle, the Oracle database. So very, very different. Between I guess 96 and 2000, I mean, salaries probably doubled to tripled, and the internet just brought out just this. I mean, there was just. I mean, it was like an open field. Every time a new platform or is sort of released, there's just sort of this wave of innovation that builds upon it. And I was fortunately, I thought, able to join several very interesting startups very early. I mean, early in my career, which at the time I thought they were pretty revolutionary. Outside of so I left Oracle after about 2 years, and I joined an internet advertising company called AdForce, and it's one of the top 2 display advertisers at the time, after DoubleClick, which is still around. But essentially, the idea behind it was that we would crawl websites, figure out what the most, I guess, distinguishing keywords were on a page, and then target ads against it. So I mean, if you kind of just as that idea, it essentially was AdSense, and we built out. The technology was working. It was display advertising versus I guess versus search advertising, but it was just a phenomenally interesting idea at the time, and kind of rode the wave where we got up to the point where we were serving close to 1 billion ads a day, which I mean probably isn't as much now, but back then, I mean, it was maybe. I mean, we had Yahoo and GeoCities as our 2 of our bigger customers. So we were serving most of the internet, most of the ads on the internet, which is kind of a phenomenal thing to sort of think about, at least back then. Right. So I'm probably rambling a little bit, but as I've gone on in my career, the teams have definitely gotten the trend is teams have gotten smaller. The cost to creating companies has gotten cheaper, so that you can do it's just a phenomenal amount with just essentially just 2 people. 2 people can actually if you think about just to pull a recent example Instagram, which was I think so we know those. I know those guys from my my last company because we were kind of sort of a similar space, but they essentially created a service that's serves hundreds of millions of people with 4. I think they only had 4 people up to the point that they acquired by Facebook. I mean, that's just so long story short, I mean, you could if you have the right idea and I mean, it's possible for you and a buddy to kind of make a big difference in the world.
Yeah. Well, I think it's very interesting for people these days who, it's, I mean, if you've only been learning software development for a year or 2, then you don't necessarily have a lot of context as far as where did it come from. And I think it's really interesting to get a sense of perspective around what it was like to work in a team 15 years ago or 20 years ago, and then 10 years ago, and then 5 years ago, and then it hopefully gives us a good sense of perspective as far as what could be possible in the future. But actually, in the realm of kind of walking things backwards, I am quite curious to hear, especially from folks who've lived through Internet Bubble 1.0. Like how did the downturn affect you, and the way that where you were, and the teams that you were on, and things like that.
Yeah. So I guess the one piece that I learned, though, which probably is somewhat relevant to your audience, is that you're going to probably go out there at some point and get a job, and it's sort of important, sort of understanding, I guess, especially if you're at a non-profitable, non-public, I guess a non-profitable company, just what you're sort of getting into. So, capital was like free-flowing back then. Maybe somewhat akin to how it's been sort of thrown around recently, in that, companies would raise $40 million and then blow through it. I've heard crazy things about like companies blowing through $10 million just for a launch party. You have to, for me personally, I was part of a company which was actually making money. We successfully went public. We were actually bought by one of the big tech bellwethers at the time, CMGI. CMGI, however, was basically built on top of a house of cards, and so when their stock valuation, it basically went down maybe 95%. They looked to cost cut, and I think they had bought somewhere around 50 to 80 companies, and they didn't know what they had, so they actually shut us down, even though we were making money. They shut it. Well, they gave our. It's kind of interesting. They started moving our business to. They bought 4 ad providers, I think, at the time, and they had one that was, I guess the first one, Engage. They basically tried to move all our customers over to Engage, and then they attempted to shut us down. So it was actually quite shocking to have like a company that was was kind of on its own power, was publicly listed, and then immediately, just because of finances, they cost cutting, it just disappeared. The company so I actually left AdForce before CMGI shut it down, and I joined another company which was doing I guess the equivalent of Google Analytics. We were doing analytics as a SaaS service, but it was paid. So also sort of interesting. This is also so when the bubble actually did burst, the investors, I think, clawed back money, which is also possible when you raise money. Like if you don't have control of your board, they decided to cut their losses, and it was the one time in my career that I actually got laid off. So
it's gotta happen once.
Yeah. So I guess long story short, when you're it makes you look harder whenever you're evaluating your job opportunities. There are multiple things you have to look at. I guess when you're first getting in there, I think the primary thing that you want, at least for me, just from my perspective, I think there's probably a year or two where I think it helps to be part of a good team where you can actually, cut your teeth a bit, essentially. But you want to be on this path where you're constantly learning, and as part of that, smart people usually gather around the best opportunities. So you kind of have to both be able to evaluate a good business opportunity, so that you have a chance to kind of grow, and then also if a company is doing that, they will probably acquire the best talent, and so you want to put yourself into the best position possible, essentially. At least that's the way I would look at a job sort of early in my career. And then if you're entrepreneurial, there's another route you can take, but if you're going to take a job coming out of school of this nature, look for. You don't necessarily have to pick an already established company, but you should definitely evaluate sort of the business. Learn to evaluate how the business that you're joining, in terms of is it probably a good investment, and what are the people like? What are their hiring standards? So one false positive could be you could join a company and they could be really, really into you, but if their hiring practices are poor, they will probably attract poor talent sort of overall. So it may not be the best situation for you. Even yeah, so like the hard interviewers, I mean, actually, the harder the interview, usually like the sort of it's sort of one indicator of a potentially a company that might be able to have a good outcome, just because yeah, you need to attract sort of the best talent, and being
Right.
part of a team with talented people will increase the velocity that you learn, and so you definitely want to try to take advantage of that. Sorry if I'm rambling.
How do you find those teams?
It's-
Especially if you don't have, a pre-existing network through sort of several years of career.
yeah, that's sort of a great question. So like, I mean, it's sort of interesting. Like, so like what the way the way things like happen now versus before. Like, I mean, so in the past, I mean, getting a degree from like a good computer science college was sort of like your ticket into these places. But I mean, we're more and more transitioning to the skill based economy, where like the way they evaluate you isn't just like, did you go to some top tier school for computer science. You have the ability to put your work out there, and for the most part, most recruiters that I mean, most good recruiters now do, and hiring managers, I mean, they will look at you, not just for, not just to get a sense for who you are, but like if you have code out there, I mean, that's the best way to figure out whether you're capable, I mean, what you're capable of. So like, to the extent that you can like work on projects that, are on GitHub or whatnot, definitely do that, and definitely list them on your LinkedIn or your resume or your LinkedIn, and I think that, like, if you get somebody who's really trying to find a gem, because it's really hard to find people these days, people will dig through your code, and if you have, like, you've worked on an interesting project or shown some aptitude, I mean, it'll increase your chances that they'll reach out to you and try to ask you to interview. But in terms of like actually finding good companies, I mean, like, again, like, you want to put yourself in a position where you talk to as many companies as possible. A couple ways that you can do that now, which are a little bit different. Like, there's a service out there called Hired. I don't know if you guys have heard of it, but essentially it's like a reverse auction for hiring, where they, instead of like you applying for a job rec, companies are applying for your services. Definitely check that side out, and then to the extent that you can, when you're looking, just try to get in front of as many opportunities as you can. So like, engage recruiters. Reach out to hiring managers directly if there's something that you're interested in. I mean, ask friends. You want to put yourself in a position where, like, if there is, I mean, at any given time, like, you want to just give yourself options. So like, you want to be able to look at a company and just say, like, I mean, have multiple good situations that you can potentially get into and pick the best one. So
Right.
yeah, I mean, don't get lazy when you're looking for a job. I mean, don't take the first job that's offered to you.
It's all about the hustle.
Yeah.
Well, so, I just want to note that this is definitely a Q&A driven event. So if anyone here is listening, please feel free to use either the Q&A app, the little widget that's on the Google Hangout on Air, or you can send questions in any way that we can hear you, whether that's in our Slack channel, on the event page, on Twitter, or whatever. We will definitely try and get those in and get those answered as they come in. But just to continue forward with you, Andrew, one thing that I was kind of wondering was so after, and this actually I guess comes chronologically speaking, after you'd kind of survived that layoff situation and moved on to the next role. The next role you had was much more on the managerial side, right? And I'm kind of curious, how was that transition, and then what did that teach you? What perspective? How did that perspective change the way that you viewed, or you might have viewed, your path up as a developer?
Right.
Yeah.
Yeah. So yeah, one of the things is, like, I mean, engineering, unlike maybe other professions, tends to be slightly more merit-based, meaning like, in order to become a sort of an effective, like, engineering leader, you have to be. I believe you have to be technically strong, because, I mean, to the extent that, I mean, it's hard to not have good aptitude. I mean, like, so it's hard not to have, like, strong aptitude and at least in my opinion, effectively a technical team. So like there's definitely like a progression. Like when you're starting off, I mean, you're as a more junior engineer, you're going to be, I mean, just focus on trying to get like functionality working, and then as you start graduating, I mean, start moving up the chain, you get more responsibility. So it may be, maybe that you start leading design more. It may be that like you're even taking customer requirements and figuring out how to build something, but like to the point, I mean, you want to get to the point where like you can interact with like a product manager or your CEO or whoever's kind of giving you product features and be relied upon to kind of to be like a heavy lifter and basically build the important pieces of functionality of any service. There's at some point when a company gets big enough where all of a sudden when the engineering team gets to about, I would say around 3 or 4, there's a little bit of overhead that it sort of needs to happen in terms of coordinating and making sure that like the product you're building is like equitably split up so that you have the division of labor and you're able to kind of move as a team versus just relying on like an individual's expertise. So that for me, I mean, I was fortunately given that opportunity. I mean, somewhat earlier in my career, and yeah, I mean, the transition was, I mean, I wouldn't say difficult. It's just your perspective in terms of what your focus is sort of changes a bit. So it's not just about you getting stuff done. It's about creating a framework for other engineers to be productive, and I think that if you're coding and this will sort of come naturally for people at around maybe the 5 to 7 year mark for a lot of engineers, where they accomplished enough where they're not worried about the mechanics of doing so, but then they can also take on the additional responsibility of making sure a project completes with resources reporting. I mean, not reporting to them, but the resources that they're responsible for. So
So from your perspective, having gone through the process of building teams and trying to identify developers, can you just put us inside your head a little bit in terms of like when it becomes clear that there's a need in your organization to bring someone new onto the team, how do you then walk that forward in okay, you need to specify the role and identify somebody to fill that role and then interview them, like what's going on inside of your head so that we can kind of as potential interviewees get a sense of like why you're on the other side of the table and what you're actually looking for.
So it really depends on the size of the organization that you're building. So in general, my preference personally is to hire, I guess what they call generalists or full stack engineers. To me, like so you want people that so if you were to think of yourself as as if you were implementing like a product by yourself and you have to understand all aspects of like how the product works. I feel like developing both that mentality of like being able to just take ownership of these are the features and this is how we're going to do it. These are the technologies we're going to use. This is how we're going to structure our code. That mindset, I think you can't get enough of. Like people that are just able to build stuff end to end without additional help from anybody else. Because once you're able to do that, it allows you to be able to transition to the point where, where if the team gets picked up and you need to set up a reporting structure, you can be comfortable taking like those types of folks and giving them maybe people who are more specialized and make them productive. It really as I was saying, it really depends on what the organization needs. So like early on, I would probably hire like a full stack generalist engineer probably for the first six hires, maybe 5-6 hires. I mean, depending on what kind of product it is, and then you start filling out, I guess, the team with like things where your skill set may be lacking. So, a lot of times, like many good engineers tend to not be like great at doing markup, or maybe they don't like doing front end, and in which case you would shift focus and fire another full stack engineer who's actually comfortable doing comfortable doing like CSS, JavaScript, that kind of thing. So,
So how do you know when you found a good one, though? Like, how do you actually
yeah.
seek and locate and then identify good talent?
Okay, so that's actually a great question. So like so I mean, similarly from like the from my side, I mean, again, I would spread a relatively wide net. Uh, in that, like, I mean, I would try to consider as many candidates as possible. So the one interesting thing is like it kind of depends again, like on how much. It's definitely hard to recruit at a smaller company. So like in a very very small company, I would probably go to people I know. Um, but like so, say you've raised your Series A and now you're just looking to hire non-friendlies. Um, yeah. So also another point, like also for early hires, I would probably get referrals too, just because like I mean like it's really hard to it's hard to find good talent. And so like if you can get someone to vouch for you, that usually speaks volumes, because there's I mean a lot of things that kind of influence whether a person will be a good fit. I mean their technical expertise, but then also important, this is like how well you work in a team. So like there are people that kind of really talented, but they're sort of lone wolfish, in meaning that they can't like some of them are very territorial about code. I mean, there's all these things that could happen that are maybe undesirable from a team perspective. But you want someone, I mean, essentially, I mean, smart, works hard, gets things done, and team oriented. Yeah, I mean, you have to like the people you work with, otherwise, especially with like deadlines, and I mean, you don't want to create a team dynamic where the team isn't communicating and working well with one another.
So instead of referrals, or I guess beyond the fact that maybe you ideally would like to have someone to vouch for this person, how do you actually specifically identify whether or not someone has those skills if you maybe aren't quite as familiar with them?
Like, so back to what I was saying, like, I will look at people's code. I mean, so like, I mean that if it's out there, I mean, it kind of gives you a sense for like, I mean, like, how organized they are, what, can they, I mean, so one thing that like I kind of sort of like to see from engineers is that like I like engineers who can create readable code. So it's kind of like so writing code. I mean, in some ways, it's kind of like writing a paper. If you revise your paper enough times, I mean, it sort of gets better and more maintainable. So I mean, I definitely look at people's code, and then in terms of just like I mean, the real test is when you bring them in for an interview, and then just my own personal style. I like, I mean, some senior people might have a problem with this, but I like having interviewees build something. For one thing, like it measures all the things that I guess would be required in the real life workplace, which is like, I mean, you're going to be given features, some problem set, which you're going to have to kind of internalize, figure out how to and figure out how to create a working system for. So my interviews. My personal interview, like, or one of them tends to be just like I give you some time to kind of build something. It's like, and it'll be, I mean, it could be something like build me blackjack or something like that, and I'll give you maybe a code structure, and then make sure that there's a language you're familiar with, and then just have you see how far you can get in the amount of time allotted. But I mean, the number one thing that I think that all managers want, I mean, we want definitely people that can build things. I mean, can like take, I mean, the objectives of the company, translate them into into working code. And then there's all the other soft skills that you need. Like you want them to build, you want them to be reliable, be able to communicate well, communicate efficiently, which you also determine like through an interview. But like, I mean, the primary thing is like if you can code, I mean, definitely interested in talking to you.
Yep. Cool.
Yeah, and so from like I guess all your perspectives, I mean, like I just can't stress like you have to. I mean, coding is one thing that I feel like I mean, there's a steep, long learning curve, and you definitely the more you do, the more things you build, the better you'll get at it, and then I mean, stuff like an interview will come easily if you've built enough things. So, yeah, just keep your mind open, build stuff, and also don't, I guess, always be on the lookout for new technologies too.
Hmm. Cool.
I don't know if I completely answered your question.
Yeah. Was there a question out here?
Yeah, Andrew, great advice, by the way. Soaking it all in. I do have a question though, in terms of communication. So you talked about how you worked on the business side as opposed to just just coding and on the engineering side. What effect has working on the business side or non-engineering roles, how has that changed your perspective in communicating with others, not just as a coder, but like, how to effectively communicate what needs to be done and how to connect with people and how to, just generally how to connect and communicate effectively.
Yeah. So I mean, the one advantage I think that it's kind of interesting actually. So like, the one advantage I think that engineers have in terms of like, so if you have built something, you can kind of at least in your head figure out what's possible, and that's like it may seem like sort of obvious to an engineer, but like to non-business people, um, I mean, sorry, to business people, I mean, they aren't able to do that. So like, you can create a plan that's sort of actionable, where just by knowing that it can be built based on your experience, um, and yeah, yeah. So to the extent that to the extent possible, like I mean, like having any sort of technical skills, even if actually if you don't like decide to do like programming, like I guess at the end, I mean, like for the rest of your career, like knowing what's possible, I think is like just like it's hugely valuable. It'll help you understand like other businesses, other products, just because you kind of have a sort of the spidey sense of like how something works, and it's yeah, it's sort of a great advantage. I don't know, especially I'm maybe slightly biased in that in the Bay Area, it's probably definitely necessary, but yeah, it's yeah, definitely a strong card to have.
Thanks.
Sorry, I'm not sure if I completely answered your question.
Oh no, it did. Great answer. Thank you.
Any other questions from you folks here or anyone outside? Certainly have a few here as well, but I want to make sure everyone has a chance.
Just had a quick follow-up. Are there any, just to follow up to my previous question, are there any red flags that you've seen in the past, in past teams and past engineers, like things that are not good and things that could be improved in general, like any stereotypes?
Yeah, I mean, kind of hard to. Okay, I mean, in some ways, yes. Like, so, like, there's one thing that I sort of noticed with like this newer generation like the newer generation. So, the productivity tools. I mean, the way that the way that technology is advanced, like, I mean, most technology now is geared to making the developer like able to release a feature like very, very quickly. And one of the things that I think is somewhat important to be like, if you want to be like engineering to be your mainstay, is to have a solid understanding of like how the internals of things work. And I guess what I mean by that is like, okay, so traditionally, like the way I guess Cal teaches its curriculum, I mean, they teach it at this pretty set the curriculum is such that like you learn like certain basics that like they sort of build upon each other. It's like how, it starts with like maybe how a processor works, how memory works, and then you learn assembly, you learn C, and then as you go up, the systems built on top of those, like maybe just those core things like operating systems, I guess operating systems, compilers, and databases. I mean, three things I think people should. I mean, if you have the time, just try to take like a course to kind of understand like sort of how they work. It will help you, I think, in a variety of ways, so that when you're like actually in an interview, you can make better design decisions about how to structure things. So like one of the things that's like sort of I'm sorry, I'm going to just like talk about this maybe a little bit too much, but like as you start building a web service, one of the sort of interesting things is you have to be able to scale. I mean, people are concerned with being able to scale a product to essentially everywhere out there in the world, and I think those fundamentals help you understand how to build the next layer. Sort of the next layer up. So like when you graduate to the point where you have to worry about like just like creating a service that virtually everyone, an unlimited amount of traffic can see, or a large amount of traffic can see. You have to learn how to, you have to learn how to build that. And there's just a variety of skills and things that you will have to learn, and you will never understand them unless you kind of understand sort of the basics. So yeah. Yeah, again, I don't know if I completely answered your question, but
Oh no, it
yeah.
did.
So
Thank you. Yeah, because here, like when we learn things at Viking Code School, we like let's say we're learning Ajax, for instance. We actually build Ajax from the ground up using JavaScript, so that kind of
yeah,
really helps understand what's going on under the hood, and I feel like that's a very good approach into learning things and before using them or while you're using them. So yeah, that's a great answer. Thank you.
right. That's a good question. Actually, I mean, they're okay. So in terms of other like maybe sort of red flags, I mean, like so, yeah. So technical depth. I mean, like you'll definitely see some. I mean, just to kind of give you guys like like people will. I mean, if they come from like a very, if depending on their sort of their age, some of them will ask you core CS questions like in part of interviews. And like what I mean by that is they'll like, okay, what's the difference between a pointer and a reference? Or how do you what is a memory leak and how do you prevent it? I mean, they'll ask you things that they think like fundamental things that they think a person should know, and that will maybe trip up some. It may trip you up if you are completely caught off guard and don't understand it. And like it's kind of weird. Like the culture is to. I mean, is to not have like a false positive in hiring. So like, unfortunately, like the way that sort of translates tactically when people do interview is they will sometimes ask you things that they may not necessarily be fair, but they're trying to make sure that they aren't letting on somebody that that's going to actually be detrimental to the code base essentially. So unfortunately, you have to be prepared for that, and that's just like sort of part of interviewing as an engineer. But other than that, just like like answer truthfully, think through your problems, try to, I mean, think through the problems, and speak clearly, explain your designs, explain your thinking when you're on interviews, and I mean, that'll give you the best shot at trying to get an offer.
So can I actually flip the question on its head a little bit and ask, what do you think are the characteristics of the ideal developer? The perfect person, the perfect hire.
It's really interesting. So perfect hire, huh? Now you're making it. Okay, so okay, for me, I mean, it's a combination, I guess, of a couple things. So like, completely technically proficient, and by that I just mean like you should be able to, I mean, take any feature out there and like sort of know how to build it. But beyond that, I think like one of the things that actually is sort of underrated that really has a really deep impact is like, so like, I don't know how you say it, having good judgment or common sense. And it would be like by my second one, which is like, like, so one of the things about like building, like really, you can spend almost an infinite amount of time improving code, but knowing when you have something that's like sort of good enough and what how to essentially manage your time such that you're actually providing like sort of optimum value for your time is sort of like a very hard to test for, but very, very important. And then having like I guess a good business, like when I say business sense, a good product sense, I guess is what I should say, meaning like the last thing I guess most product people want. I mean, when I say product people, these are the people that are kind of usually in charge of like telling you what features to build. Last thing what product person wants is to have to articulate point by point what's needed. They would like to be able to, at a very high level, kind of give you what they want built, and then have you just follow up with like questions in terms of like what. In terms of where it's ambiguous, so that they don't have to like create like this massive spec to get something implemented. So yeah, technical skills, good product sense, and then good judgment would be my top three.
Nice. And I guess related to something that we were talking about just before this started, you'd mentioned kind of the role of passion and specifically that there are some folks who maybe were not quite as passionate about development, who got into development through college or through some maybe decision that was made long ago. Do you mind just kind of talking to the role that liking what you do has in the growth and development of your career?
Oh, right. Yeah, so I mean, like the thing is, like, you know, like, so one thing is that, like, regardless of like what you decide to do in your career, like learning this stuff, I think, is like hugely valuable. So there are definitely people who decided not to, like, you know, I mean, so when you, as an engineer, you have actually a couple options. I mean, once you sort of graduate, I guess. So I mean, going to the point where, like, so again, just like knowing, like, being a form engineer, like, I think that usually puts people in an okay position to be like a product person or product manager, simply because as long as you can articulate features in a way that allows an engineer to build them, and as long as you could shift to becoming more, you know, business focused. These days, another like really common thing you hear is like, so these growth hackers, growth marketers. So like, I think at almost all levels now, like in companies, like having technical skill can allow you to do certain job functions extremely efficiently, just with like a little bit of programming. So some of these roles would technically not be like, you're not building a product, but you're building something that maybe drives traffic or figures out how to buy traffic. Knowing how to program definitely. I mean, it may not be your primary skill, but it will definitely serve you well, because, like, if you think about it, like, you have some tedious task you need to run, or some task where, like, you know, the decision making can actually be encompassed in an algorithm. If you can code it, I mean, that makes you infinitely more efficient. And then if you don't have to ask somebody to do it for you, I mean, that makes you just like even more valuable. So yeah, having the skill, I think, is good. Like, but if you, I mean, the people who are, yeah, really passionate about building things, eventually they will. I mean, I think if you put enough time in anything, you will eventually become almost a master at it. So yeah, that part's, I think, definitely key if you want to, like, I have a long career, because one of the things is, like, technology. I don't know. Should just warn you. Technology does change. Like, so over the course of, like, just my career, like, I mean, Oracle, I started off programming in C, AdForce was C++, Teralux was C++. Then I did Java for about 10 years. I did Rails, .NET, Django. I mean, I've probably built a product in most frameworks at this point, and it's sort of out of necessity in some ways, just because, like, it's these frameworks have definitely gotten more productive over time, and like things will continue to change. Like, I mean, like Objective-C and Swift may be popular now, but, like, I mean, there's no guarantee of what's going to happen like 5 to 10 years from now. Like, you have to love technology, because you're going to have to learn and to continue to evolve as your career goes forward.
Great. Well, I know we got to be conscious with your time, so I think maybe if it's possible we could leave on one note, which is one that I typically will ask, which is that if you were sitting in these seats, if you were at this phase in your career, talking to the you who is now, what is the advice that you have for the younger, fresher, earlier version of yourself?
Okay, I mean, so I guess I get it, because the one thing that I mean, I don't think I had the ability to maybe do this as much when I was younger, just because of, like, the things that I had mentioned about, like, it being just hard to start and it was just harder to start, like, a project on your own. But, like, to the extent that, I mean, now that you can, especially if when you're looking for your first job. Try to build something that you can demo. I mean, I think that, like, actually having a demo for you guys, or going out there, is probably one of the strongest selling points you can create. Like, look, and, like, do something, and also do something that you're passionate about, because I think that'll allow you to put, or encourage you to put the time and effort and love into it, to make it something that's something that's impressive. So yeah, I mean, get out there and together, build something, and like try to get people using it, because like I mean, I think a lot of great ideas, but like, yeah, I mean, if you can show passion for something and put that and embody that in code, I mean, I think it'll be a first good step into your careers.
Great. Well, thank you so much for that, Andrew. Thank you everyone else who's here with us right now and who's listening now and later in the future. This is the Viking Codecast with Andrew Tso, and I just want to say thank you everyone. Thank you, Andrew, and that's a wrap for tonight. So have a good one.
Thanks, Andrew.
Thanks so much, Andrew.
Thank you so much.
Thank you very much.